here we have SimWorks loaded. This is a OpenFoam based software. SimWorks provides us 14-day trial license. I tried the tutorial of glider flow with the SimWorks. Now we can go through the process. So first we need to create the project. We give a project name. And then we create a geometry. We give a name for the geometry. The next process is to create the simulation. We created the simulation and we give a name for that. Now we go to the setup and load the geometry. We load IGES file, glider.iges, and then load the geometry. You can see in the screen the glider as well as the outer domain. Now we'll look at the simulation parameters. This is a steady flow. We'll change the iterations to 300. It's a single processor. It's a single phase incompressible flow. No thermal. Gravity is on, and we use the turbulence RANS K omega SST model. Air is flowing as a fluid. It has the density value as viscosity value, and default initialization and reference values are kept as it is. Now we'll check the regions. We'll modify the origin. We'll give the values as per the tutorial. Now you can see the model is shifted to the new origin, and we'll also change the outer domain values. And we can see all the parts are arranged in different part groups. We can view the boundary. This button hides the outer domain. You can zoom it, see the glider. Now we can see the the parts with different options as shown here. First we'll see with the part groups. You can see the part identified as part 7. You see the mesh group. And then we can see with the boundary condition types. It shows it's a fixed wall. And with the part names, it shows all the parts in different colors. Now we'll go to the mesh tab. We'll enter the base cell size as per the tutorial. We'll also enter the point in the mesh and also the radius as per the tutorial. This creates a point inside the domain. You can check the created point. Yes, it is inside the domain. Now we'll check the mesh values, surface level and edge level to be provided. The tutorial says 5 as a size, but we give 8 to get bit coarser mesh. It helps us to run faster. So we give the value for all the boundaries. Surface mesh 7, we leave it with the default values initially. Surface mesh 7 was the glider. Now we save the setup file. So it shows 100%. So saving is completed. Now we can proceed with the meshing. We hit the mesh button. Meshing takes quite some time. Now the meshing is completed. We see 100%. Now we can start running the calculation. But before starting, we can check the setup file. Since we have completed the meshing, I think it's good to save the file. So we save the database. Give a file name to save it. Now we hit the run calculation button, but first we need to confirm all the setup. So we'll take a quick look. About the physics settings, all looks okay. Fluid properties look okay. The reference pressure looks okay. We'll change the iterations to 100. Now hit the run. Since we changed the setup file, it's asking us to save the setup file again. Setup file is saved. Now we see the run is completed. I just saved the simulation file. I'll show you the steps to save the simulation. Hit file, export simulation, go to the folder, give a file name, and then hit save button. That's it. Now we check the results. So we loaded the results in the sim2 using import simulation. We can see the flow in the trailing edge of the glider looks good. The U velocity is shown. Now we'll check the residual plots. The residual of Ux, Uy, Uz and pressure are showing good trend. We'll check the forces. We have CD, CL, CM roll, CM pitch, CM yaw showing good trend. Now we'll take a look at the contours. We'll zoom it. So what we see here is the velocity plot. It shows the trailing wake. We can also change the variables and the section. First we'll see different variables. We'll We'll see the pressure plot. It looks good. We'll see the CP plot. It looks okay. Now we'll plot U mean, P mean. Pressure shows a good trend. Thanks everyone for watching. We'll see you in the next video.